Here to learn about morphoecological design. All right, very good, very good. So I have with me Jenda Michl, and he's going to talk to you about that and biomimicry and the architectural form.
Thank you, Arns. We all know about green architecture. We've heard everything there is to hear about green architecture. We know about thermal massing. We know about solar gain. We know about siting it correctly. We know about using recycled materials. We know about water reclamation, everything we've heard. That's great. Do it. We need that. But that's not what I'm here to talk about. And those are all things that humans were doing thousands of years ago, and we're trying to figure out how to do it again. What we need to do, I'd say, is look at what the world offers us, what our technology and our knowledge has brought us as tools that we can actually progress past redoing what we knew thousands of years ago. So with that, I'd like to point out or highlight a few items from nature, and bringing up that, let's look at, say, the flower. Why is the flower, the shape, the color, the smell, everything else, and why are they so diverse? Why are there so many of them, and they're magical and beautiful? Let's take a look at, say, the water lily and the cactus. They're both flowering. They're both in extremely different contexts. One is floating in water, one is in the middle of a desert. And yet they both have flowers and they're vastly different. Some aspects of the flowers are basically the same across the board. They're probably odoriferous, colorful, etc. They serve the same purpose, but they all go about it very differently. And they are brought about, this incredible diversity is brought about by the fact that they are all in very different contexts, and they have to react, and they have to fit into exactly their location. So bringing this back into architecture, we can say, okay, let's create a frame of reference, a context for viewing architecture as a reaction to its specific location. And how can its specific location inform not just the location of it, say, so that it gets passive heating, or it's not in a floodplain, or other basic things. Let's say, how can the form of the architecture itself, the shape of the building, for lack of a better term, be a reaction to its context? So we now have, and Frank Area and many others have proven, the ability to make a building that looks like anything we could possibly want it to look like. It can look like a vase, it can look like a flower, it can look like a spaceship, it doesn't matter. We can build it. So the question becomes, why are we assigning a specific form to these buildings? For the most part, it is because it looks cool. Right? Does the Disney concert hall really benefit its context through its shape? If you want to take on extra heat and get blasted with sun, then you can stand over here and it will do that. But that's not really a benefit, and it was not intended. They had to sandblast the thing because it was doing that too much and it was bothering the city. So let's look at how we can actually take that ability to make it any shape and say, okay, what would nature do? What kind of shape would nature give to this building, since we can build anything? And so we can look at a few factors. Let's say we can look at the wind, the sun, the water around a building. So we can look at the urban context of it, we can look at the economic context of it, and we can say, all right, let's say for the wind, how could we actually benefit? How could this building be shaped in a way that it actually benefits from having the wind coming through the side? We can figure out what the prevailing winds are, how strong, whatever it may be, and say, okay, can we harness this and, say, funnel it through over the vents so that it's actually amplifying the suction out of the building? Can we funnel it and focus it into generators so we can take, say, a prevailing 5-mile-an-hour breeze off of an ocean and actually, through the form of the building, focus that into generators? How can we can do that? We have turbines. We know that we can focus wind. Let's use it. We've got water. Let's say we've got the amount of water, rain coming in, snow that builds up, has weight, whatever it may be. How can we utilize that? How can we collect that water, use it for inside of the building, use it for plants, bring it back into the city, provide back to the neighborhood, or perhaps we have it located, say, next to the LA River. And that river water, and any river water, can always, especially at the bottom at the mouth of the river, benefit by being cleansed. So what if we were to divert that water through nearby buildings? Let that actually passively cool the buildings, put in nature into the buildings, let the basically filter the water coming through the building, create greenery, oxygen inside of the building, and then filter the water, bring it back out, and saying, okay, world, here's cleaner water, thanks for letting us benefit from it. That can come across in all of these different aspects, whether it's wind, rain, sun, how is the building shaped to benefit the most from the sun? How are we calculating, if we make it this shape, where is the shadow going to fall? How can we benefit from that? Is there a shadow falling on the building that we should know about when we're designing it? Culture, where's the traffic? Does the city actually need things? Does the city need parking? Does the city need transportation? What are the people that use the building actually going to be doing? Do we know that there's going to be 1,200 people coming through at lunchtime? How can the form of the building actually be informed by that known need? So this is not really groundbreaking thought. There are great architects out there that have been doing this. There are great examples of buildings that start to do this. Maybe not in all aspects, but in some. So what I'm actually here to talk about is, one, open the eyes about it, but say, okay, let's propose that we have the ability to use the technology we have, the computers that we have, and say, okay, let's build ourselves a program. Let's build ourselves a piece of software so that we can utilize the power that has and say, all right, we have these various factors that we can input into the program and say, all right, we know we've got this wind, we've got this sun, water, whatever it may be. And we could actually program something to take these inputs and vectorize them, create them into essentially forces that this program would be able to say, okay, what do you need the building to do? What is your program for the building? How many rooms do you need? How many square feet? Whatever it may be. You can put in parameters that are required. And then you can put in these forces and say, okay, I'm going to have a little slider for each one. That way I can modify the importance of this aspect of the building. So in real time, we could potentially come through and say, all right, here's my requirements, here's the computer, and based on how I set these sliders, it will actually generate a physical model, a form of the building that reacts to how we've set it. And with that, we could potentially in real time play with the sliders. And we could sit here playing with how we're valuing these, and this is where the human part of it comes in, because this is not to replace architects, far from it. They become more valuable. And we can actually take that and say, all right, let's in real time play with the form of the building so that it is maximizing its benefit to the ecosystem of the city and to its exact location. There are, to my knowledge, there's nothing like this out there. I'd love to bring it about. If anybody knows anything about anybody that could help, wonderful. In the meantime, I will just sit here and play with it in my own office. I've done a couple of projects, one that specifically does divert the LA River through the building, through the neighborhood. It does funnel the wind, it does generate electricity from that, and it's doing it in both directions, so the form of the building ends up looking like a piece of pasta almost, because it's funneling both directions of the wind, morning and evening opposite directions coming off of the ocean, and it, I think, works. And instead it creates a building that is sculptural, but it's sculptural for the right reasons. I think my time is about up. And the last thing I'll say is I do have an architecture company. I do kind of do this stuff, so I'm not just talking out of nowhere. And I did bring the bench that you can see behind me here, which was designed also based on starting with the need, which is I want something that's actually going to bend with me and not against me. The idea derived from wanting to sit at a desk and lean forward. So I designed a desk chair that leaned forward, and then I adapted that technology and made this bench. I encourage everybody to sit on it because it's fun. Thank you.